So recommender systems are very exciting, very powerful, and it's really one of the most successful niches of machine learning that's everywhere in e-commerce. And so let's move on now and move on from recommender systems to reinforcement learning. So reinforcement learning is a very interesting subtype of machine learning because it's very close to human learning. So in reinforcement learning, an algorithm learns a policy on how to act in a given environment. The algorithm essentially operates in real time. So it's not like supervised learning where the algorithm sees a huge chunk of data all at once and then decides what to do with it. An algorithm operates in real time, can take some actions and knows what happened in the past, how it was rewarded depending on its actions, and is trying to predict what's going to happen in the future, what's the best action. And that's very important. So the points are not independent and the actions are sequential. So reinforcement learning has many applications in the real world. So you can teach a drone how to fly itself. You can teach a reinforcement learning algorithm to learn to play any game. This could be backgammon or chess or whatever. It's used a lot in finance as well. It's used a lot to invest in portfolios or to make trades, etc. And obviously in robotics. Reinforcement learning has been very successful recently through DeepMind, because DeepMind developed a reinforcement learning model that managed to beat one of the world champions in the game of Go, one of the most complicated games in the world of tabletop games. Actually, much more complicated than chess. So it was considered an unsolved problem until reinforcement learning came to the rescue. And this has made reinforcement learning very popular. Another area of machine learning is semi-supervised learning. So in some scenarios, we're faced with the following situation. We have lots of data, but the majority of our data is unlabeled. So this is the case, for example, with images, genetic sequences, or web page classifications. However, not all unlabeled data is equal. So some of the unlabeled data points might look really similar to some of our labeled ones. So what if we actually use some kind of heuristic in order to label those unlabeled data points and use them to train a model? And what if we actually repeat this process again and again until we utilize as much of our dataset as possible? So this is the main premise behind semi-supervised learning. And in this image, which is being gained from this paper which I'm referencing, you can see how semi-supervised learning works. So we start in the upper left corner at A, and we have labeled data for two different categories. Okay, we have labeled data for the crosses and for the small circles. In picture B, we see the labeled and the unlabeled data. Okay, so we see the small dots, the crosses, and the circles. So our model learns from the labeled data, and we see this in C. It has learned that the circles and the crosses, they are two different categories and they can both be expressed by these elliptical shapes. So once we do that, then the algorithm finds other unlabeled data points which fall within these shapes and then labels them. So it assumes that if an unlabeled point is around here, then it's most likely a circle. It intuitively makes sense. Similarly, if an unlabeled point is around here, then it's a cross. And I mean, it makes sense because these are so far away from each other. So it labels these points and then it trains itself again. And then after a few iterations, it comes up with that. There are some points here on the periphery, on the margin, which you can't really say whether they're a good example of this category or this category. It finds points around here, you can see this around here, which clearly belong to one or the other category. And this is a very powerful way to use some of our labeled data. Basically, it's very cost and time efficient, right? Otherwise, if, let's say, you're in the domain of images or genetic sequences, you'd have to spend time and money to come up with these labels. And now, active learning is the last type of machine learning that we're going to see. It's a special case of semi-supervised learning in a sense, where the algorithm is able to query the user or some kind of oracle that holds the absolute truth about the data points. It's also called optimal experimental design. And let me explain how active learning works. You can see this very nice and clear in the pictures at the bottom. So we have a problem where we have, let's say, the green class, green squares, and the red triangles. And you can see that in some cases, these points are intermixed and, we can't achieve perfect separation using only the two variables we're using in this graph, but that's fine. What I want you to observe is that not all points are created equal in this graph. There are some points in the far left and some points in the far right. And these points in the far left, it's clear that they belong to this green square class. And this point in the far right, it's clear they belong to the red triangle class. It's 100% clear that's the case. So when the time comes to draw a margin between them, would you do this or this? So what's the problem with this? Okay, here, this margin is using data points from around here and around here. But these points are not very informative, right? It looks like the points around here in the middle, they're more informative. So this margin actually it's more correct because you see it uses only the points which are very, very close to the margin. It uses only the points which are borderline. So these points are very close to the other group and these points are very close to the other group. So the main differentiating factor moving from one class to the other is really around here. So what active learning does is basically thinking along those lines. Okay, so not all points are created equal. So if I want to maximize my performance and learn as fast as possible, then maybe I can just query a human or an oracle about the points which I think are the most powerful for learning. So this is how active learning works. So it can start to learn and then it's like, okay, I think I want to draw a margin somewhere around here. And could you let me know what the value of this data point is and this data point and this data point? And then it learns along the way. So it can be a very interesting way to speed up learning, especially when you don't have many data points. Active learning can work alongside the human, but also in some cases it can work alongside an oracle that contains the true values of the points. It's a bit of a niche area, but it has its uses.